Hello, friends. Hi. I am Gabe Levine. This is John Arfa. We're gonna twist a tale for you about machine music. Why are we here? We're gonna make some music for you. The end deliverable is some stuff that was made by a computer. Let me tell you a little bit about myself. I played music in a touring indie rock band for a long time, a band that you've never heard of because it was indie rock. And I became a programmer, and I work at a company called UTC. I work on like jet engine data, and I try to hack on code and music in my spare time, which is why we're here today. And let John introduce.
Yeah, I'm John. I do statistics and machine learning stuff, and I haven't played music since middle school. But Gabe, we used to work together at a company called Magnetic, and he asked me, do you want to work on this with me? And I said, definitely, it sounds awesome. And here we are.
So last year, I gave a talk here at Pi Gotham that was essentially taking weather data streams and transforming it into, had an algorithm, a very simple algorithm that transformed it into kind of lovely ambient music. Well, I thought it was lovely. And it was just super simple, super lame, super fun to work on, made a lot of really interesting sounds and patterns, and was really into it. But this year I was like, what the hell, I want to learn about machine learning. So decided to apply some machine learning to the simple thing that I did last year. Yeah, this is it. So kind of a little bit more complicated than it was last year. The idea is basically to take a whole bunch of raw MIDI files as training data. We're using a character predicting deep learning model that John will talk about because I don't live in that space. So I transform the MIDI into hex, and then take all of those hex documents and feed them into the model, which gets trained, which then outputs more hex as text, and then I swap that back into MIDI, and then I just plop it into GarageBand, which I'm like kind of embarrassed of saying that. Yeah, someone that played music and recorded music, but it worked really well for this thing. All right, so John's going to talk about what an RNN is.
Right, so big caveat is that I am not at all going to teach you fully what an RNN is. I'm hoping to give you a bit of intuition about what it does. If you already have a vague understanding of what neural nets are and how they work, I think this will help. But at the end, I put some suggested reading so you can read more in your own time. So a current neural net is basically, if you think of a neural network as data goes in, goes through a bunch of layers, and then you get output. Recurrent neural net is that at every stage of this, if you're doing this based on the sequence, at every stage, those weights in the middle are going to change. So to compare that to vanilla neural nets are on the the left. And that's you have one input, one output. It's nice and simple. Once you add recurrent neural nets, you can start doing more interesting stuff. So image captioning, where you give it one image, and then that returns a sequence of text. At every stage, it's predicting the next word, and that's based on the previous words. You can do sentiment classification. You give it a sequence of words, and at the end it tells you, is this person happy, sad, angry, hungry, whatever. Machine translation, and this is actually the same, very different task, but the exact same architecture as what we're doing, where you give it a sequence of stuff, and this, let's say words, and it's going to predict the next the translation of that word. Or what we're doing is we're giving it a sequence of music, and it's predicting the next note or the next bar, for example. And that's not what we're doing, but you could do many-to-many, which is video classification, for example. And I'm not going to spend too much time on this, but this is a very minimal example. Let's say you're doing from characters, trying to predict the next character in a stream of characters. You start with H, and you can encode that as what's called one-hot encoding. So in this imaginary universe, we have a vocabulary of 4 letters, H-E-L-O. So H is represented by 1, 0, 0, 0. Goes to a hidden layer, and you get an output, which tells you the next letter is likely to be E. You do that again with E, but you'll notice that the hidden layer has changed a bit. And that's changed based on what you've given in the past and based on what it predicted. And this is, in this toy example, like it's never going to be this confident about the right answer every single time. But I just wanted to give you an idea of how this works. He mentioned briefly that we used a character-based network. And so because we were kind of putting this together a bit late in the game, and we wanted to get something very. I think it's a mark of pride to me. And because we wanted to put together a minimum viable product very quickly, we started with a model that does this exact thing character to character. And we basically, he'll talk more about this, but we basically just encoded music into fake characters and used the off-the-shelf algorithm. Slides will presumably be available later if you're interested in reading more. And I'll pass it back to Gabe.
Okay. It's kind of like a morning show, even though I don't have cable or watch TV, so. But I remember them very well. Okay, so someone was just asked me to go over this part of it, so that's what I'm doing. Yeah, so because we're using kind of a text-based machine learning algorithm, I thought it'd be great to just encode the MIDI itself directly as hex, because it kind of is human readable. Yeah, so these are these blue arrow bits. Yeah, and so I used two great music libraries. One called Music 21, which I used to. It has like a classifier to determine the key, or to I suppose try to determine the key of a piece of music. So we added that as another input into the models. I started by not having the key in it, and you'll hear from some of the crazy attempts of the stuff that came out that it's atonal music it exists. It's awesome, and we made a lot of it. So yeah, I was like, oh yeah, like what's wrong with this? Let's add the key to it. So yeah, using Music 21 to grab the key, and this great MIDO library to just kind of like abstract away dealing with MIDI files and all that stuff. I'm assuming people know what MIDI files are. It's just a thing that, it's a encoding of, let's say, musical notes and performance. So it has like in it will be like a note number, which will designate to, like, let's say, a key on a keyboard, and a velocity up, for which you would strike the note, and then the time that it holds the note. So it's a nice way to capture performance. And then also, there's a lot of MIDI on the internet to use as training data, which I will get to in a little while. And then just right back into from hex to MIDI as well. I realized that you probably shouldn't catch generic exceptions. Use this as a guide, not as Python. Don't do that. All right, so for the training sets, this was kind of interesting. Like, kind of the goal of this whole exercise, aside from, like, for me, a deliverable in the music world was always some music and something to listen to, which we'll get to, and you guys can put together your critiques of that. Yeah, I mean, so the training sets, this is very interesting. So the goal, aside from having music, sorry, I lost my train of thought. The goal for having this project, aside from actually making something that you can listen to, whether you hate it or not, at least something to a beginning point to talk about, was to learn about neural networks and deep learning. And I have never really, I've kind of worked a lot in the fringes of that, as in like feeding a lot of stuff, building pipes to feed stuff into this like black box to train, and then like using the predictive outcomes. But I've never worked in training a neural network. So this was really interesting for me, and I've heard that it is more of an art form than it is a science. I don't know. Maybe you can correct me, data scientist, not data artist. But it was really interesting because you kind of like you're feeding into it just a bunch of stuff, and like I started with like, okay, I'm just going to throw everything into it and see what comes out. And for me, it was just like a really fun process of just like, shit, I'm just going to throw all this stuff into it and see what comes out. I'm going to change some parameters that I don't really know what they do, but John will explain them later. But then it sounds totally different. And then of course the variance of the pieces was interesting to just feed different composers in, and like different and different. I used a library of folk music, like Irish and Celtic folk music, and a bunch of songs from the Civil War. Like all of that was just really kind of interesting to see the outcomes. Unfortunately, I didn't really approach it in like a very scientific documenting way of like, oh yeah, I fed these following things in, and then I'll do that next time. Yeah, so John's going to talk a little bit about some of these lessons learned, and then we'll listen to some of the results and see how that goes.
Sure. So this first bullet point is a bit cryptic. Basically, when you're actually using an RNN to predict something new, you have this parameter called temperature. And basically, the short version is that high temperature makes it be wild and crazy and try new things, which can be fun. Low temperature makes it super conservative and boring. And well, for this, the better stuff you'll hear all use lower temperature. But there's a balance. This is a bullet point that should be on every machine learning talk ever. More training data is good. More training data is far better than better model or anything else. Mixing different types of training data, classical plus folk, not so good. And for me, the biggest takeaway was how off the shelf this stuff is. I knew that generating music from RNNs is something that's been done by a lot of people, but I was very impressed with how easy it was to just plug and play. I'm exaggerating. It wasn't that easy to plug and play, but
It's pretty easy.
pretty easy.
Yeah, it was, yeah, I mean, and like I said, as someone that, myself that hasn't really touched, and by the way, we used PyTorch. I don't think we said that. It was a great not music library, but a machine learning library developed by people at Facebook where John works. Yeah, it was really cool just to get in there and plug away. So, all right, as someone that has played written music for a long time, I will tell you, always the first pieces that you write are terrible. So that's the caveat. Right, so this guy here, let's see if we can see how this sounds. That sounds awful.
So one thing I wanted to interject is a lot of people who don't deal with machine learning have no clue what the term epochs means. What it means is one epoch is running through all your training data once. So that doesn't tell you how much training data we use. It just means that we ran through it all 10,000 times for this one.
Cool. So yeah, we don't want to listen to that anymore. Yeah, and I just put some random Calder video up there just because. Yeah, so this is a bit more a focused training set, running in a shorter amount of time. And you can see that it's starting to like figure something out. Does it sound terrible out there, or is it just on this side of the thing? I mean, aside from the actual notes that are being played, I mean, the quality of the sound. Let's say it sounds distorted, right? Well, I'm sorry about that. Clearly, nothing I can do about that. So okay, well that's too bad. Yes, the distortion is not. It's not on my side of things, I hope.
Blame AWS.
Blame AWS. Yes, this is folk music, and I wish the sound quality were better. For some reason, it's not sounding so good coming out of this guy. But this one you can hear, like you can actually hear it teasing out. The music itself is much simpler, just kind of pure melodic forms. Let's see how weird that sounds. Right, and that's not even feeding the keys. Someone say, wow. It's like, wow, that didn't sound like crap like the asked to. Yep. And then with feeding the key as an input to the training set, and then also having it run much longer. I don't remember what this one sounds like.
Islands.
Yeah, and I had it as a marimba for some reason. Yeah. So you can see that that it's. Let's see what the classical one with the key. Let's see if this doesn't sound crazy. That sounded a little bit crazy. Yeah. So, but what is interesting is actually you can't really hear it because of the distortedness of it, but it's starting to, there is some dynamic movement between the parts, which I find really interesting. It's starting to build chords that make sense. Yeah. So it's just for me, it was just super fun to be like a mad weird mad scientist on making stuff. I guess this is the last one. I had a lot of them in here. That might be my most favorite one. I just like, there's so much, it sounds ridiculous, I feel like I'm talking about. It's so dynamic. No, I find it's just really interesting. It's like the more it's learning and the more information that we're feeding it, the more interesting it becomes. Which to me, as someone that has like struggled with writing music, it's just been great to play around with that. Yeah, so that's the end of our talk. Thank you for walking with us down this journey of experimenting with machine learning and making music with it. I'm going to post everything, all of the code that we use to build all of this stuff on this repository, which has stuff from last year's talk, so just ignore what's in there right now. Wait at least a day or two. Yeah, thank you very much. Questions, comments? Yes. Yeah, so the question is, have you ever considered a training set that incorporates music theory so that the model itself can learn, I'm just going to paraphrase and extend, the model itself could learn what music is prior to being introduced with another. Yeah, I mean, absolutely. That would be really interesting.
You could build a data set that's just chord progressions. So you could build a data set that's just chord progressions instead of notes and pauses and all that, and maybe do another one that's chords to a bass line or something like that. Yeah.
So like part of the question makes me wonder, is that already sort of baked in? Like you feed it 130 pieces by talk, that's foundation for
My instinct is, yeah, my instinct is that it'd be a matter of having enough data and a complex enough model. It should absolutely be able to capture that. Generating data, he did all the generating data, and that was a pain in the butt, wasn't it?
I think it was more training the model itself was, but yeah, generating data was kind of a pain in the ass too. Yeah. Yeah, I kind of, that was my theory, my thought as well. Is like, in fact, that's why I didn't feed it any keys actually, because I was like, oh, it's so smart, the thing will just figure it out, after like having run for 4 hours. But
You only used 2 layers, right?
only used 2 layers. So
More
of
layers,
course,
more music, I think you definitely should have been able to do that.
I'm sarcastically saying, of course. Why would 2 layers only be?
The question is, why would 2 layers not be enough?
Yeah.
Because if it's not good enough, add another layer. I mean, add more data, add more layers. That's, until it works, right?
what happens if you sample it for longer? Does it get completely crazy after one?
That's interesting. If you sample it for longer, so do you mean like having more epochs? Oh yeah. So the reason why they're so short is like our lovely two GPU AWS instance kept running out of memory. If I tried to generate longer, oh trust me, I wanted it to like, I would have had you guys sit here for a lot longer through. But yeah, so it just kept running out of memory. But that's an interesting question. Yeah. So we were constrained by memory limitation there. Yeah.
Okay. Where did you find that corpus of music, and how did you interpret that?
Sure. I Googled classical music MIDI, and I just found websites that had MIDI, and I wrote MIDI files. Yeah. So I was just grabbing as many MIDI files as I could find on the internet, and my original thought was like, oh, I would love to just have Philip Glass MIDI music, but that doesn't exist on the internet. But so there are programs that you could just feed in sheet music. So you can have like there are programs where you can just feed in sheet music and it transforms it into MIDI. So that would probably be my the next step of like, I just didn't want to have to pay for something that did that. So there was no free one that I could see. Oh, there are, I didn't find one. Yeah, okay. So, but the thing that transforms the PDF into MIDI itself was a program that I had to pay for, which is really cheap of me. But
like if it's in musical notation,
yeah.
and you need to
Right. So, no. So okay. So just to back up for a second. So you can get PDFs of sheet music. There are programs that can then convert those, read those PDFs, and then output MIDI files of those PDFs. And then for us, we just would transform it into hex and then feed it right into the.
Oh, you can do it.
Yeah.
Can you elaborate more on what went horribly wrong when you tried to mix the 3D?
Was that one of the examples we had?
Yeah, one of the examples we had of were just toss everything in there, and it didn't make any sense of it. And I think just to go back to that idea of like, I think the Bach music it's just very complicated, right? So, in a way, I think, and then back to the original question back there is like going back to feeding it fundamentals. Like I think of kind of like approaching it from like an indie rock standpoint. It's like the 4-track demos or something. Like going back to feed it just a bunch of like rudimentary songs really to learn what the form of a song is. And maybe classical music is a complicated thing to figure. I mean, I still don't play classical music, right? To think about that one, but it's complicated. So maybe I should have just like focused on much more simpler musical forms that which kind of was like why I was like, oh, let's try some folk music. And of course, there's a lot of folk music out there. Right, it's a great question. Did we only work with instrumentals? I just thought it'd be. For right now, I wanted, like, the Bach stuff was only keyboard works, so I tried to keep it within, like, an instrument, at least to I didn't want to confuse it, but I so totally want to, like, explode it into, like, other instruments, and the vocals would be so interesting, It would be super interesting to do that, yeah. Yeah. And then training with the word, I mean, like, and then have it generate words, which is actually what it's designed to do. Maybe it would be happier and make happier music.
I figure with vocals, I mean, you could do something with, it'd be hard to make it, if you have a very complicated structure to make it do words and music. If you're just doing like a way of transcribing sound waves into something that the model can be fed, maybe you can get some sort of more of the sound of vocals rather than the actual words.
Yeah, I'm more interested in how the feature would mimic human vocals.
Right.
Training that.
Right, yeah, it could be fun to like feed it a bunch of stuff and watch the nonsense that comes out, which is kind of what we did with, just notes.
I actually, one of the original ideas was to feed it all of the works, literary works that Bob Dylan was influenced by, and just see if it could, like, having been trained on the same stuff that Bob Dylan was trained on. Well, it obviously won't, but it just would be like another fascinating, So then we could have music and lyrics by laptop.
Back. Right.
Because they're kind of learning and playing at the same time. It's abstract.
Yeah, no, I think you're hitting the nail right on the head. John wanted to start with jazz, but like
We had the data for classical music, right?
we had the data for classical music is really but no, I think you're totally right. I think jazz would be such an interesting, and that would be such an interesting comparison to make. Like how does jazz training, how will it train the thing? It's a very rudimentary way to say it.
1 minute warning.
1 minute. Any more questions? All right, thanks. One more. Sorry.
So what are the next steps for you guys? Like, do you want to launch the AI as an artist on Spotify?
Yeah, that would be awesome. Yes. You think I'm joking? But yes. No, I think it'd be. I actually like. I don't play music anymore. So like, I would love to be able to figure out a way to do more of that. I think it'd be fascinating to generate. It's like straight out of a William Gibson book or something. It's like, yeah. I would love to keep doing more. So we should do that. Except that we have jobs and stuff. Thank you so much, guys. It was really, really fun. Thank you.